Welcome to my channel Living Linux. In this video I want to have a look at Ubuntu on the Orange Pi RV2, which is a RISC-V single board computer. So you can download the Ubuntu image from their website. It's stored on a Google Drive, so you might encounter an error where it says that downloading is not possible anymore because it seems that Google will limit the amount of downloads per day. But if you have a Google account, then just log in with your Google account and then try again. And then probably you can download it. And otherwise just try it the next day then perhaps. I don't know when exactly they will reset the amount of downloads per day, but yeah, just try it on different times of day. So you can see that we're running with the Kai X1 CPU, and that way you can see that we're running with the Orange Pi RV2. Now, one of the tests that I usually do is WebGL Aquarium. So let's try that. And then we'll let it fully load. And then, 30 frames per second. And yeah, that's not a lot, but we don't have a fully working GPU driver. So yeah, this is as good as it gets at the moment. Oh, now it drops to 20 frames, 21 frames per second. Well, and then it goes up. Anyway, YouTube playback. Yeah, there is support for the VPU, but unfortunately not in the browser. So yeah, it's probably best to keep it at 480p. So you can see here 480, 30 frames per second. So if we try that, yeah, it's still not a very smooth experience. So even 480p, 30 frames per second, and you get the occasional frame drops, but I think it is watchable. So like I said, there is access to the VPU. So for instance, if we try the 4K VP9 version of the same video that we just watched. So you can see here, VP9 4K. Now if we try that with MPV, then it's not 100% smooth, but it's definitely running on the VPU, because otherwise the CPU isn't powerful enough to decode a 4K video file. So that was VP9. I also have H.264. So you can see here, H.264, high profile, that's almost 4K, but with 24 frames per second. So if we try that with MPV, so when you have local video files and it is in one of the supported video codecs, then yeah, it is able to decode them in hardware on the VPU. Now, does this mean that we also have a very good GPU driver? Unfortunately not. And I tried the game 2048 on my Banana Pi F3, and even though this is not available for RISC-V, or at least it hasn't been built for RISC-V, but you can run it with Box64. Well, at least I was able to run it on my Banana Pi with Box64. But here we have an issue with the GPU driver. So as you can see here, I already downloaded it. I set it to be executable as a program. And I also installed Box64. So if we try to play it, then you can see that Box64 is doing its job, but there is a graphics issue. So, well, I hope that it will be solved quite quickly. Because like I said, I was able to do this on my Banana Pi F3. Now, as it was booting, I also saw that they start Docker. And all you have to do is start this command. And then the first time you run it, then it still needs to download everything in the background, but and well, it looks like that, oh, well, it just took a while, but in the end, here it is, hello from Docker. And now that became a bit unresponsive. So perhaps I still have too many things in the background, I don't know. And also this does not necessarily mean that all your Docker scripts will automatically work on RISC-V, because your scripts might reference some components that are not available on RISC-V yet. So keep that in mind. And when we mention the boot process, I also updated this image, and then it was complaining that there's differences with these configuration files. Well, my choice was to keep them as is. I don't know if that was the best choice or not, but anyway, yeah, you can also choose to see the difference. So here is one example of the difference. So perhaps someone with more knowledge can make a better decision. Or perhaps I just chose the best decision just by coincidence. Anyway, let's go to something that does work. And that is Llama.cpp. So with Llama.cpp you can run large language models, although yeah, this is a modest CPU, so it's not a good idea to really run the really large language models. But yeah, you can build it. Just follow the instructions. So just get the code and then build it like that. You might run into an error message. Yeah, that it's not able to find curl. I think that's installed, so I'm not really sure why we get that error message. But you can use this switch. Llama curl is off. So that means that you just add that with this last line. So, but once it's built, then you also need a large language model. So I went with small language model, 1.7 billion parameters. And I think I went with Q4KM. So let's see. Do we still have that somewhere in the cache? No, let's take an example from here. I think that there should be an example. Yeah. Let's try it like this. The path to the model. That's the path to the model, and then should be able to run it like this, right? And I can show you that it's running on the CPU. So Let's try that. And then you can see that the CPU cores do their job. Well, looks like this model is a bit chatty because I didn't ask for any other notable high mountains, but well, we'll just let it run. Meanwhile, I can show you the results of the Llama benchmark. Where'd it go? Where'd it go? Yep, there. So with a 1.7 billion parameter file, 4-bit quantized, yeah, single-digit tokens per second. So that is slow for such a small model. But yeah, this RISC-V chip is not very powerful, but also it doesn't consume that much energy either. So well, like I said, it's looks like a chatty model, or it is put in a chatty mode. I don't know. If it keeps going after this one, then I think I'll just interrupt it. So, but the good part is that you can build and run Llama.cpp, and yeah, I recommend running it only with small models, because otherwise it will only get slower. Now, one other AI thing that also works is Stable Diffusion through OnnxStream. And I used Stable Diffusion XL Turbo. So you can just follow the instructions to build it, but you will run into an error. And I think this part works without a problem. And then when you want to build OnnxStream, then you run into an error. It's not that hard to fix it. So it will tell you that architecture is native that doesn't work for RISC-V, and that the architecture string needs to start with RV32 or RV64. So we can make that happen. So if you go to OnnxStream and then the source CMake list, and then looks like line 51, or at least at the time of this video, because the developer he does try to keep it up to date, so that might change in the future. So instead of native, I just use RV64GCV, and then you should be able to build it. And yeah, running it, that will take quite some time, so I'll just show you the result here. And as you can see, that took almost 20 minutes. Stable Diffusion XL Turbo, only one inference step. But I think the result looks reasonable. It looks okay. Yeah, so it also has box64 in the repository. So yeah, when I tried that, then unfortunately it didn't work. But that doesn't mean that you can't play any games on this single board computer. So yeah, on the website it doesn't mention that it is available for RISC-V, but at least with this Ubuntu image, then Battle for Wesnoth is available in the repository. So let's see. Yeah, let's do this afterwards, the GL mark. So you can install it just like this. Sudo apt install wesnoth and wesnoth-music. And then where did it go? Where did it go? There it is. So let's do the battle training, the tutorial. Let's go with Conrad. So we need to move Conrad next to the wizard. Okay, so let's attack. So let's end our turn. And then the Quinten gets a turn. And let's go to the village to heal. Now, if you want to play this game, I guess, well, it's not too hard to install it, and you can follow the tutorial just by yourself. And yes, the last thing, this OpenGL benchmark. So yeah, I think there is support for OpenGL ES on the GPU. You do see some activity on the CPU, but I think that if it was fully running on the CPU, that you would see a higher percentage on the CPU cores. And well, this will take quite a while, and yeah, if you want to see all the results, then just run it yourself. So there's probably plenty of other things to explore, but I think this will give you a general idea of at least what I got working on the Orange Pi RV2 with this Ubuntu image. I will also check if I can get Beyondbu working, but then probably I have to play around with the DTB files. So that is something that, yeah, I don't have much experience with, but we'll see. Who knows? But I guess that you can do some interesting things already on the Orange Pi RV2 with this Ubuntu image. And yeah, if you have some interesting things that you are able to run on it, then just let me know in the comments. So this is all for now, and I hope to see you again in my next video.